Hi guys, my name is Shan A. Hiranandani, and today for my reverse engineering project, I'm going to reverse engineer a wired mouse. So in this video, I'll be covering how the hand motion is transferred to the monitor through the mouse. As we open the mouse, we can see that a big PCB or a printed circuit board, which consists of three switches: left click, right click, and the center click. It consists of a scroller and a main input output channel, a photo cell, and a LED bulb. Now, the motion is transferred through the LED infrared. So when the LED is switched on, it goes through the glass tube and it is reflected at the mouse pad, which contains ridges at a low angle, which is then reflected to the optical mouse sensor through a lens. Now, if these ridges were missing, moreover, if we use the mouse on a glass surface on a smooth surface, it wouldn't function because the ridges is what is required for making the whole mouse or the motion to be sensed by this sensor. Now, the working of the optical mouse sensor is basically by taking a final photo and comparing it to the initial photo. Now, the mouse sensor, once it takes two photos and compares it, it deletes both the photos. Now, this one photo comprises of 40 by 40 pixels, which is then compared with each other and gives us the direction of x-axis and y-axis. Now, a DSP is used for this cross reference, or it uses the cross correlation algorithm to find out the path or the direction on how a mouse works. Now, the difference is cross correlated by the final and the initial photo, which is taken by the image sensor, which then gives us the motion of the mouse. Now, coming to the scroller or the rotor of the mouse. In technical terms, it's called optical rotary encoder, which primarily consists of an optical sensor or infrared LED emitter and a rotor. Now, the rotor consists of equally spaced spokes, which determine the direction and the pulses, which is measured by the CPU. Now, when the rotor rotates, it breaks or disrupts the flow of the light beam which is emitted out by the infrared LED, which gives us um, a graph like this, which measures the pulses and which is interpreted by the CPU of our computers or laptops. Now, this rotary motion is measured due to the angular distance traveled by the rotor, which determines on how the application or the website screen is moved up and down. Now, one would question how the direction is measured. So, the spokes, when they move down or rotate through the axle of the rotor, it hits the beam either on the left optical sensor or on the right optical sensor, which determines the up or down rotatory motion of the rotor.